Mercury's day. This is the position of planet Mercury on day 1. A man is standing on Mercury and the sun is directly overhead to him. Now let us calculate what a day on Mercury is. The planet has moved around the sun from the position A to position B and the man is standing in the same position after 58.7 days. This means the planet has completed 360 degrees of rotation on its own axis, but around the sun it has completed only two-thirds of its axis. You can see this in this figure, which means 240 degrees. The sun is no longer overhead, even though the planet has completed one rotation on its axis, because the revolution of the sun has not yet completed. In this picture, the planet has moved from position B to position C. It's another two-thirds of its axis, that is 240 more degrees around the sun, but the sun is still no longer visible to the person. However, it has already completed one rotation on its axis by the time it has moved from point B to point C. This journey again takes 58.7 days, but despite completing one complete rotation, it has not yet completed its revolution around the sun again, so you cannot see the sun overhead. Another 58.7 days has elapsed and the Mercury has moved from position C to again position A. That means another 240 degrees on its axis around the sun. After three such journeys, it has moved 720 degrees around the sun, which means two complete revolutions. Now you can see that the planet has again reached its original position and the sun is directly overhead. That means for every three rotations on its axis, the planet completes two revolutions around the sun. Now let us see the mathematical analysis of this. The planet takes 58.7 days to complete one rotation on its axis, whereas it takes 88 days to complete one revolution around the sun. Remember, it moves around the sun in the same direction as its rotation on its axis. Remember that the apparent position of the sun in the sky is a result of both daily and yearly motions of the planet. As per the daily and yearly motions of the Mercury are concerned, they both are oriented in the same direction. In this picture, the black arrow below the planet shows the direction of the sun and the black arrow above the planet shows the direction of apparent motion of the sun in the sky as a result of the movement of planet around the sun. The orange colored curved arrow below the planet shows the direction of rotation of planet on its axis. The orange arrow above the sun denotes the apparent direction of motion of the sun in the sky of Mercury as a result of the rotation of Mercury on its axis. By the time it is clearly evident that the two apparent motions of the sun in the sky of Mercury are oriented in opposite directions. This means that the apparent velocity of sun in the sky of Mercury is the difference of these two different types of velocities. With the help of this information, we can calculate the length of day on Mercury planet. Now let us discuss what is a sidereal day and a solar day. A sidereal day is the time taken by the planet to complete one rotation on its axis or 360 degrees with respect to some distant star. The further the star, the more accurate the result is. This is because the daily movement of the planet around the sun is negligible with respect to the distant star, whereas the same can't be ignored with respect to the sun because the sun is quite close to the planet. In the picture, you can clearly see that the distance of the star from the planet is huge compared to the distance of the planet it has traveled in one day. In fact, the distance to the star is not exaggerated in this picture. In fact, it is much more than the pictorial representation. Even the closest star to our solar system, Proxima Centauri, is about 9,000 times the distance between the Sun and the last planet of our solar system, Neptune. That means the distance of the star to the planet is quite huge compared to the distance of the planet with the sun. That we can see easily. The same cannot be said in the case of the sun. as the planets are moving around the sun as well as along their own axis of rotation are quite close to the sun, their daily movement around the sun is a negligible portion of their orbit, which means by the time the planet completes one rotation on its axis, it moves quite a significant portion of its path around the sun. In extreme cases like Mercury, it is about two-thirds of the orbit, and even more dramatic case involving planet Venus, by the time the planet has completed one complete rotation on its axis, it would have already completed its one complete revolution around the sun and moved a little further. In case of planets close to the sun, the ratio of their daily motion around the sun to the total length of their orbit is quite significant and not negligible, even though it is small. In case of our own planet Earth, it is approximately 1 by 365th of its total orbit length, which is definitely not negligible. That's why we know that 1 year of our planet Earth is comprising of 365 days. Now let us do the mathematical calculations. Now we all agree that the sidereal day means the time taken by a distant star to complete one apparent revolution around the planet, which is the result of planet's axial rotation. In simple terms, it is the time taken by the distant star to complete 360 degrees of revolution in the sky of the planet. Solar day is the time taken by our sun to complete one revolution of 360 degrees in the sky of the planet. Now let us calculate the solar day of Mercury with the help of sidereal day and year. Mercury takes 58.7 days to complete one rotation on its axis from west to east. This means the sun moves from east to west in the sky of Mercury at the rate of 360 divided by 58.7, which is equal to 6.13 degrees per day. It also completes one revolution around the sun at the rate of 360 divided by 88, which is equal to 4.09 degrees per day. 88 days is the time taken by the Mercury to complete one revolution around the sun. Left picture here shows the sun's apparent motion due to the planet's revolution around the sun, and the right picture shows the sun's apparent motion due to the planet's rotation on its own axis. Now, as the two apparent motions of the sun in the sky of Mercury are in opposite directions, the sun moves 6.13 minus 4.09, it is approximately equal to 2.0 degrees in the sky of Mercury. So, the time taken by the sun to complete one revolution in the sky of Mercury is 360 divided by 2.04, which is equal to 176 days. The same can be proved by the experiments also. This means the sun, which is directly overhead in the sky of Mercury, takes 176 days to reach the same position again. So, one day on the planet Mercury, one solar day on planet Mercury is as long as nearly 6 months on our planet Earth. This shows how slowly the planet Mercury is moving around its axis. Now, let us see what happens when the planet completes one revolution around the sun. In this figure, we can see that the planet has completed one revolution around the sun in 88 days, but as we have seen earlier, the time taken by the planet to complete one rotation on its axis is 58.7 days. This means it would have completed 88 divided by 58.7, which is approximately equal to 1.5. This means it would have completed one and a half rotation on its axis by the time it has completed one revolution around the sun. So the sun is exactly in the opposite side of the planet from where the man is standing. That means sun is no longer visible in the sky of Mercury, even though the planet Mercury has completed one complete revolution around the sun. 1.5 days have elapsed, but still the sun is not visible to the person because its sidereal day and solar day are quite different. This is an extreme case in the planet of Mercury. On our planet, we cannot see this much of difference. This all we can see in some other videos. Thank you, one and all.